Welcome again, Professor Malte Witte TV. We are very proud and honored that you take your time to exclusively show and explain your experimental kit, which everybody is able to buy for a low cost, to look for themselves what is happening, and you show that there is another kind of wave compared to the electromagnetic wave, the Hertzian wave, which everybody knows and learns in school and so on. And with this kit here you show that there's something else in the wave world, and the idea came from Nikola Tesla. You made a thorough research on Nikola Tesla and got the idea, okay, I rebuild what he has done but in a smaller scale.
Yeah, so it is.
And now we are very thrilled that you explain exactly what it is and how it works, and the very interesting results of it.
Okay, yeah, thank you, Henning, and welcome to this presentation. I do this since more than 20 years, more than 10 years that I show this experiment, because we have developed it in 1999. That was the first time that we were demonstrating these rebuild of Nikola Tesla, and we at that time have collected the experiments in this manual, which is called Scalar Wave Technology. And we are just working on the translation of a collection of ideas about these experiments, which had been sent back by customers, because we have customers for this experimental kit all over the world, more than 1,000 universities, companies, private people, and even medical hospitals and medical doctors. So what we showed just at the beginning, because today we have a lot of other applications in addition, but from the beginning I show you the very first experiments, how we started on with this experiment. So with this experimental kit. Here you have the Tesla coils as a transmitter coil and a receiver coil.
So the coil is in the green plate.
Here it is.
Yeah, and it is from two sides.
Yeah, I explain it as a transformer. It's an air transformer. I have here another coil, so I can show you that from the button we have the primary coil. And you are able to select 5 or 4 windings.
Yes.
And on the other side you have the secondary coil.
Yes.
And this is an air transformer. That means we have no iron to lead the magnetic flux. Yes. It's only in the spreading fields of the magnetic flux. And then we have the connections of the secondary coil, and the primary coil is the connection in the center, and here the so-called earthing line. The connection in the center is connected with the antenna, and the earthing line is normally connected to the earth. Tesla was using, but Tesla, and this is one difference to the original Tesla patent, Tesla was using very high voltage, about 60,000 volt, and we are working only with 2 volt for the LED that they shine, as you can see here, 2 LEDs, so that we have problems to use the earthing or the earth as a connection between transmitter and receiver. We are using only a cable, and in this cable here, in this cable connection, the currents are floating, and this is the connection or the line back, because the whole system is acting as a a resonant circuit, an oscillating circuit. So this is standard technology, I would say, from the standpoint of today. But this standard technology seems to have some very special aspects which are new and unknown.
Short question. This on that part, on the receiver part, the coil is identical to the coil from the transmitter?
Yeah, it's identical, but inside the experimental kit we have different coils with twice of the length of the cable and half of it, so that we are able to combine as well one coil which is using half of the wavelength and the other one a quarter of a wavelength. This is what Tesla
where are those coils situated? Can you point on them?
This we have to find out what the resonance frequency is. Now we don't see it. I have to tune it.
No, but you said there are additional coils in the kit.
Yeah, we have. Normally we have in the experimental kit additional coils. I have not here. But
yeah. Okay, you can swap them with those.
Because if you want to reproduce what Tesla originally did, he was using a quarter of the wavelength for the transmitter and half of the wavelength for the receiver. But this mixing is not necessary at all. But if you want to reproduce all these experiments, you can do it. And this is why we call it experimental kit. What I show here is the minimized version we have made available for 800 euro, and we call it a demonstration kit. You see.
In this here are no coils no more. It's only this coils and this coils. Okay. Yeah.
So this is a standard generator, function generator, and this here is a counter, counting the frequency. So this is standard technology. There's even one difference to those which are available in the market, because our coils have resistance of about 10 ohms, complex resistance, and normal function generators have an output resistance of 50 ohm, so they could be overloaded. This is a hint for those who want to reproduce the system, but who don't want to buy the whole experimental kit, but only the coils. This is possible, but then they have to pay attention that they do not overload their own machines. This is why in our kit always the generator is inside, so that you can reproduce these experiments without problems. And this reproducibility is absolutely important for scientific research. That is a necessary condition, that it is always and everywhere reproducible. And we have made it available.
And the silver balls, what is
the silver balls are only antennas, and Tesla was using ball antennas, but you can use other antennas as well. You can use only a stick, whatever you want, but the ball is the best. The best for producing scalar waves.
What kind of material is it?
It's a conducting material. It's Christmas balls, you see here. It's stainless steel.
Okay, yes.
Looks good, but you see, you can use aluminium or whatever you want. Everything is possible, but you will find out that there are differences if you change the material a bit, and especially if you change the size.
And the white tripod is isolated. The three strings.
Yeah, this is only
plastic
for fixing plastic. It's only for fixing the antenna. Here is the antenna.
But it's not conducting.
No, not conducting. Here's the connection to the center of the flat coil, which is a pancake coil, or called as a Tesla coil.
Yeah.
Okay, now let's start with it. You see, this generator here, you can select sinusoidal signals or rectangular signals. I'm using the sinusoidal signal. And then here this is the amplitude. I have maximized the amplitude. And then I can change, well, this is out of action, rectangular or other form. You see, as I have selected the sinusoidal signal, this has no function. And here, high or low frequency, I select the high frequency, and here you can see we have about 4 megahertz, 4 point and the rest. Okay, you can see it here.
Yes.
This is a standard counter, it is. Here we have an amplifier that is necessary to reduce the resistance down to 10 ohm, just to drive these coils. This normal standard generator does not have. Okay, now here we have 2 possibilities to change the frequency, and we start at about 4 megahertz. We can use lower frequencies, but nothing will happen. Only the lamps at the transmitter side are shining, but not at the receiver side. Now we look at the receiver side, and will be at the same time at the transmitter side. Both lamps we have to have a look at, and we are changing the frequency, and we get up with the frequency and look when the lamps at the receiver are shining.
Blinking.
And here you see that they are shining. That means now energy is received at the receiver side. So that we can try to find out what the properties are. If I switch off the receiver, so that is because I disconnected, then the lamps at the transmitter side, they still are on, but the others are off. If I switch them on again, you see that the transmitter doesn't feel whether they are on or off. That means this is a special property we know from radio signals, that the transmitter of a radio station doesn't feel whether the receivers are switched on or off. That means it looks like a Hertzian wave. Let's try another proof. I try to shield it with my hand, the receiver, and you see that I'm able to shield the signal, and the lamps go out. This shieldable by a Faraday cage is typical for the electromagnetic wave. So that we can say this has to be the electromagnetic wave we have found at 4.6 or 4.7, let me say, megahertz.
Which everybody is used to, that we learn in school, nothing special about it.
But we are able to prove this. If you want to prove it more correct, you have this possibility to change the jumpers from LED to DC. Then you have this rectifier. You can use a standard multimeter, or you change to AC. Then you have 100 ohm load, or you disconnect it and use an oscillograph. This would be the best solution, to use an oscillograph, because it's most direct and most correct, and then you are able to measure the current and the voltage and the phase in between. Because we know that electromagnetic waves have zero. The angle between electric and magnetic field pointer are zero. And if it is zero and you are able to prove it, this is a much better proof that this is exactly the electromagnetic wave. Well, it's a bit difficult. I have not an oscillograph with me, and this is for this interview, because we are now in Sweden, and I have it only for these conferences. I showed it some days before at Pier's conference, Progress in Electromagnetic Research it's called, and it is organized by the MIT in Boston in America. And this time this conference was in Sweden, in Stockholm, so I could show this experiment. And now I reproduce it. I show you again what I have shown on the conference, and this is now exactly the electromagnetic wave. We have to remark this special frequency, 6.7 megahertz. Now we go up again and we switch on, and you see that the lights at the receiver side go out, at the transmitter side they are still on. And let's have a look whether we find another resonant frequency where they shine again, and you will see now they are shining again. And I tune where the maximum is, and here is absolutely the maximum. So what we have reached is a situation where the lamps are shining very bright, and if I try to shield them, it's absolutely impossible. And it
Could
is
you please shield again? I
I try to shield it. I try to shield it with my hands.
Nothing happens.
Nothing happens. And what we see as well is that the lamps. Wait a minute. Here at the transmitter side, they go out at the while they are shining at the receiver side. And if I switch off the receiver, the lamps at the transmitter side, they go on. Oh, sorry.
Yeah.
So I switch it on and off and you see always if the receiver is on, the transmitter is off. The receiver is off, the transmitter is on. What does this mean? This means that here with this at 7.7 megahertz, we have a resonance, another resonance where the properties are totally different. And it means that the transmitter feels if the receiver is on. So that the radio station could know how many people are listening, so that they can get the money directly, you see, from those who are listening. Well, this is a totally different wave. It has other properties, another resonant frequency, and
you couldn't shield it.
I can't shield it. And if you use an oscillograph and look exactly what the current and voltage what is different, then you find out that there is a phase angle in between of about 90 degrees. And this is typical for the near field of an antenna, and this near field of an antenna, here I'm in the near field, is typical for the scalar wave, which is a longitudinal wave.
What is a near field?
Well, the near field of an antenna, specialists know what I'm talking about. In the near field of an antenna, I have longitudinal waves. Everybody knows it's in the textbooks. That is well known.
1/3 of the wavelength.
Yeah,
what it was.
it is, but it is disappearing at a special distance, which is the wavelengths divided to 2p, which about a sixth part of the wavelengths, and then it is disappearing, but not my system. My system, I can have 10 times the near field, and it's still receiving the whole energy, so that there is no difference.
And so it was with Tesla.
That was Tesla. Tesla was showing that his system has an expanded or extended near field, and this would be important for the use for transmitting wireless energy. Okay, this is only a small device to show that these properties do exist and that this could be usable. And as we see, the receiver takes the energy from the transmitter, and this is why we have this effect to the lamps, that they go out, so that is, if you have a load, then the voltage is reducing, and if it's less than 2 volt, then they go out. This is only indicating what happens. If you want to know it more exactly, even in this case, you have to use an oscillograph. Anyway, a scope. And the scope will tell you exactly what happens. But just to show that this is working, I think this minimized version is enough.
Very good. It's very obvious that there's a difference.
So let's now calculate, because Tesla says the following. He says, if I find out the resonance of the electromagnetic wave, which is propagating at the speed of light, and as we know that the wavelength multiplied with the frequency gives the speed of propagation, that was at 4.7 megahertz. Now we have the scalar wave, and the wavelength multiplied with the frequency, which is 7.7 megahertz, gives the speed of the scalar wave. And Tesla said, if I have the same system, and if the distance is not changed, and the balls and the antennas, nothing is changed, the coils are the same, then he says, under the assumption that the wavelength would not change, that the relation of the frequencies is identical to the relation of the speeds. That means we have a relation 7.7 divided by 4.7, which is about 1.5, I don't know, but it is about 1.5. And the low frequency corresponds to the speed of light, so that the speed of the scalar wave is about 1.5 times the speed of light. This was the calculation of Nikola Tesla. Well, this is not exact. We have to prove whether his assumption is acceptable or not. And those who have doubts have to reproduce it. They can't say only because they have learned something different, this has to be wrong. You have to prove it. And the best is that you are using a long distance. I have in my new documentation, this is the first one, the new one, which we are just translating from German. In this documentation I have a report from Austria, from a university, and they are measuring, no it's not, yeah, here it is, yes, this is the new one in German. Here I have, let's have a look, I have a report where they have measured the knots. So the knots of a longitudinal wave is measurable, and then you see, if you find the knots, then you see what the wavelength is. You're able to calculate this. And here it is described how they have these set up, how they measure. And interesting is this one, that the magnetic field strength is changing, is getting to minimum, then to maximum again, and to minimum back, and so on, so that we are able to calculate from knot to knot what the wavelength is. It's up to 80 meter. They were using 80 meter, and the electric field on the next page is showing the same property, but with a phase shift of 90 degrees, as I explained, which is now exactly measured and proved. And here you have the possibility to find out what the wavelength is.
Yes.
And if you have the wavelength, and if you know the resonant frequency where it is working, then you are able to multiply it, and then you find out what the speed is, and the speed of light is 300,000 kilometers per second. And if we look at this table of results, it's always more than 300,000, it's 350,000 and so on. It differs because here the coil differs, sometimes with ball or without ball, and another coil and so on, and with load and without load. And so everything was changed just to find out, is there an effect? Well, we see at one point we have less than the speed of light. This occurs as well. But only 1 point. The others are always quicker than the speed of light. So that this is an experiment everybody is able to prove, and if you do this experiment correct, in free space with no influence of a table or of the environment, then you will find out what happens and what the speed is. And if it is more than speed of light, well, this is reality. It is a measured reality.
So the dogma from Einstein, nothing is quicker than the speed of light, is nonsense.
Yes, more correct. It has to be said that the transmission of energy is limited, because it is only the group of a wave which is able to transport energy, and this group is not allowed to be more than speed of light, quicker than speed of light. But here we transport energy because
but I have
the
learned
lamps are
nothing is quicker.
Yeah, and this is a real problem for physics, or for standard physics of today, as this is a system to transport energy, and this can't be the phase of a wave. It has to be the group, and this is really an offense against standard physics. Okay, but these are some properties which you are able to reproduce, that this wave is not shieldable, that it is what Tesla said, transversing the whole Earth, and so on. So there are totally different properties, and what we have done is we have constructed these coils who make it possible that we produce both waves. There are possibilities to produce only scalar waves, but then I can't compare them. And this is why these coils are a compromise to show both and to compare it and to reproduce this experiment for the speed of light. Because at such small distances you can't measure any speed. It's absolutely impossible. You have to calculate the speed by the wavelength and by the frequency. Okay, well, this is the standard experiment.
Well, one question. As you told earlier, when Tesla did it, it was 42 kilometers in distance, and he got light bulbs to show light without a cable. There was an over-unity effect also.
Yes.
Is it in this kit here as well?
Yeah, this is possible, but you see that we need some sources
well, okay, that's a secondary question, but in principle it's interesting.
If they are available, then these over-unity effect could happen.
And you can calculate it with this already also?
Yes, it is possible. If you can't do the experiment with the lamps, because the lamps only indicate what the voltage is doing, that the voltage now at the receiver side is higher than at the transmitter side. But if you are using an oscillograph, I have some results here in my book, such as from the Nottingham University, where they have measured the currents and the voltage and have found out about more than 500% efficiency. Or another colleague who has even get more, it is from New Zealand, he has measured at very, very low frequency, low amplitude, at only some milliwatt, but the input power was 0.5 milliwatt and the output was more than 6 milliwatt, so that the efficiency was more than 1000%. Well, this is what they have measured, and you see, the more power you have, the less the efficiency will be, because if you have an open system and the open system is able to interact with the environment, this is what Tesla described 100 years before. If there is any source in our environment which is usable, which could go into resonance with our system and will be collected by the receiver, in addition to the energy from the transmitter, then let me say if you have about 10 milliwatt which are available, we even talk about energy harvesting. So this is very much in use of today, and the industry is looking for energy harvesting. This is an energy harvester, and if there are 10 milliwatt, and if I use this system for 100 milliwatt, I transmit 100 milliwatt, then the over unity will be only 110%, no more. But if I transmit only 1 milliwatt and 10 milliwatt are available from the environment, then I have an amplification of more than 10, that means 1000% efficiency. So if you reduce the power, you have more of a unity than if you accelerate. Because most of them say, if I accelerate this effect, and if I get more power, I can use it for as well for 10 watt or so. If I would have 1000% at 10 watt, then I would have 100 watt. So this would be a lot of power. But this is not true. In reality, if you reproduce this experiment, you will very quickly find out that it is the effect is more if you reduce the power.
Yeah, but at the time when Tesla did it, there was nothing built from humans which he could harvest, so he harvested neutrinos.
Well, he harvested energy from space because, as you say, nothing was available on Earth at that time. But he was not using short waves, as I do. He was using long or very long VLF frequencies, and these long frequencies, well, the window to space is open. Whereas short waves, the window is not open. It is there's a layer in between, which is the ionosphere, and the ionosphere is reflecting all the signals from Earth back to the Earth. But more important is that all signals from the Sun, from heavenly bodies, is reflected back to space. And this is why in this region of short waves, the ether is free. There are really no signals, and there's nothing you are able to collect. Only some artificial transmitters from some radio station or from military or whatever, they are available, and you can select a few watt or milliwatt.
So if this, what you are showing, this experimental kit is showing over unity effect, they are harvesting from some military towers, scalar wave emitters.
Whatever. Nobody knows where it's coming from, but it has to be artificial, because from space nothing is coming.
Because it's short.
Well, we had to use this frequency because it was unable for us to reproduce the Tesla original tower 1-to-1, because we have not had the funds.
It's huge, yes.
It was huge. 80 meters antenna and big coils with 1,000 of kilometers of wires.
It was Wardenclyffe Tower.
Well, I thought about the experimental tower of Tesla, which was constructed in Colorado Springs, which has had 10 kilowatt, and this has been my idea to reproduce first. But when I haven't got the funds, then we said, okay, then let's reduce it the size, and this is possible if you have higher frequencies.
Yes.
Well, the window to space has to be open if you want to have the energy from space. But you know that these scalar waves are measured as noise. It's antenna noise, you can say. And the noise we have in our environment everywhere. And we know that the noise is increasing, and the energy of the noise in our environment is increasing with the square of the frequency. So the higher the frequency is, the more energy from space in our environment is available. And this means that we have to get up to very high frequencies, and then we come in the region of neutrino power. So that these are not neutrinos at all. These are, well, it is noise, power of noise signals.
And it is noise because they are shifting in frequency and wavelength.
Well, noise is a mixture of frequencies, and as the longitudinal wave doesn't has a constant speed.
Yes.
These vortices, I call them field vortices, are always oscillating, getting bigger, getting smaller. If they are quicker, then they contract by the Lorentz contraction, and this means that the frequency is changing, and this changing over in a special range we call noise, white noise, for instance. This is typical for a mixture of frequencies, and this is typical for the scalar wave. So that we have no measurement devices to measure the scalar wave directly, but we have a possibility to measure it indirectly as a mixture of frequencies.
Because you say there are no open field lines where you can put in the scanning device.
Yes, this is a problem if you have vortices. Then there are closed field lines, and closed field lines you can't detect. You always have to have a device where the field line ends if you want to measure it. Well, these are measurement problems, and you can't say if you can't measure anything that it does not exist. Yes.
Yes, exactly. And one thing to make it clear for the audience, this shows when you send a scalar wave to this receiver that you transmit electric energy.
Yes, it is an electric wave because this from ball to ball, this is like a capacitor, a ball capacitor. That means that the electric field line always goes from electrode to electrode, and if it is propagating, the wave which is produced is propagating in that direction, it is a longitudinal wave. we talk about longitudinal waves if the propagation is in the direction of a field pointer. Mm-hmm. And this is why this longitudinal wave has these properties, and we have now detected by this experimental setup.
And you had some ideas that the technology we use today to transport electricity is very stupid because you lose a lot, and this way to transport electricity would be much more clever.
Yes, well, the systems of today, I think you think about the RFID technology of radio frequencies.
No. When I get the electricity here to the house, it's coming from a cable.
Yeah.
But here we can see we can transmit without cable and save much more, you say.
Right, because if you have a cable, you have cable losses, copper losses. They are because you're using a copper cable. But here, if we have no copper cable, we have no copper losses. This is why this system has a better efficiency. Anyway, okay. If you think about these properties, this is much better than to transmit by cables or to supply the houses by cables if you would do it wirelessly. But then you have the problem that the energy could be stolen, because if it is free in the environment, everybody is able to use it.
But you said you can modulate a code into it, and then it's not...
Yes, this is absolutely necessary. Well, Tesla at his time gave ideas how to individualize it. This was his expression. I would say he tried to modulate the signal that only those who know about the modulation and when the phase shifts are produced, if this is in use, then only those who pay for the energy will be allowed to get the energy. This is possible. It has to be developed anyway, and this system here is showing only the basic. But if we have developed all these things, then this could be used, for instance, to recharge the batteries of an electric car by driving, you see. That means that you reduce the batteries you are needing.
And you can take huge distances. You can harvest the gas in Russia and Siberia and send it all around the world. And not losing something, perhaps gaining something by the over-unity effect.
Yeah, I don't need any gasoline station anymore because I can drive as long as I want.
Yeah.
And there's no limit where to go. Well, these are a lot of possibilities, but this system is even used for other applications as well, for medical application, for instance, to transmit biological signals from one point to another. But this is improvable if you are using two receivers. You can put on here not only one receiver, you can put two receivers, three receivers, as many as you want. But then the transmission from receiver to receiver is a bit better to transmit information. We have found out because you have 90-degree phase shift between the transmitter and the receiver, and as well between the transmitter and the second receiver. That means the phase shift in between the receivers is zero. And this is better to transmit information from receiver to receiver than to use the transmitter. Well, this is one of these experiments which are very new, what we have done, and those who are interested in these biological experiments, which are explained in the new book as well, he's just to transmit information from cancer cells to cancer cells, from a medicine drug to biological samples and so on. We have a lot of ideas in the book. If you want to reproduce this, then we have made available a different experimental kit. We call it a biological kit, because in this kit you have the same coils, 3 coils and 3 antennas, instead of these 6 coils which are inside today. We leave out these coils. We have A, B, C's, which are these with half of the wavelength, because they are not necessary at all, and then they get inside in addition another receiving antenna and another coil. So this has to be remarked for those who want to reproduce these things. But now I can show you if you want to apply a bit more power, we have made available this power amplifier, and I have to connect this amplifier in between the generator, the function generator, and the coil. Mm-hmm. So you can switch them out here. They are only connected, as you see, in this way, and we connect the power transmitter in between, and on the other side we connect. No, this was not right. That was output, and here is input, ground. It's remarked. Now we have switched in between, instead of these connections, we have now the transmitter or the amplifier, and I switch it on, and then you can see that you are able to reproduce the same, exactly the same experiments. Here it is, where I have found the resonant frequency. This is the first and the second one, but you have to pay attention that you do not overload your lamps, that those at the transmitter go out and the others are on. So this is the perfect situation of resonance, as we have found out before. So if you want to use your standard generator, which is available in electronic markets, then it is better to have this power amplifier and to use it, because now you can use a standard system which has 50 ohm output, and this machine has the 10 ohm what I need for the coils. This is only a hint for those who say, well, we don't want to use this, we only want the amplifier and the coils. Everything is possible, because all these parts are made available as well in the shop of my homepage, and there you find it, and all the descriptions. So if you don't want to overload your LEDs, then you have to remove these jumpers. This is absolutely necessary, otherwise the power would be too much. And that means that we are now able to turn on the power and to find out the resonance frequency. And you see, if you have found the resonant frequency, the lamp is shining. This is what Tesla did, and we know this. It is shining even in the field. You see, that you have this ability that you don't need any connection to the coil, and it is shining. It's even shining at the receiver side. Let's have a look. Yes, here we see that even the receiver is producing the same scalar waves, and that you can have it here. It is easily influenceable, maybe influenced easily. This is normal. Okay.
I would love that with my vacuum cleaner, because I always stumble over the cable.
Yes, there are a lot of practical applications which where this system could be in use very easy and very effective. That you don't have these cables. A lot of applications, and this now has about 5 or 10 watt. The amplifier at maximum has wait a minute, about 20 watt it is, I think. 20 watt. So this is enough to drive a boat, a small boat in a pool, as shown in internet, and as we have shown on some conferences as well, or to
here in the last interview with you,
these the lamp, or to have a small airplane model of an airplane to let it move. So these things are interesting just to play with, or even for industry.
Yes.
There are some who say, well, but this system is not at all wireless, because there is still this connection here, you see. Well, if you switch out this line and use the LED again, then you find out that the lamps are shining wirelessly, because there's no connection, you see. So this is possible and may be used in a positive way, but it's no Tesla. Because the Tesla system was not totally wirelessly. He was always using the connection to the ground.
The earth was the wire.
Well, that this is possible is showing that wireless transmission of energy is possible.
Yes.
And I have it here in my hand, and it is always shining. Well, do your research if you want by yourself, but this is important, that because we have a lot of explanations in internet which are saying this is not really wirelessly, and this is why it is wrong, or whatever. I don't know what the ideas are. I always said that this system primarily was to reproduce what Tesla did and what Tesla said. I wanted to find out, was it correct, or have there been some mistakes in the descriptions of Tesla? And I can say Tesla was absolutely correct. This is important, and by this, with this experimental kit, everybody is able to find out that this is true. Yeah.
And nobody was able to come up with proof that you are cheating, or that is a bluff or a hoax, or...
Only those who never have bought this system. Those who have had it.
Yeah.
Nobody, no one who has proved it correctly. Well, there is one private institute, I think they were paid for it, that they have found out that this should be a harmonic, the two frequencies, and one would be the harmonic of the other. But what we know is that a harmonic always is in a fixed relation to the basic wave. And this is very easy to be proved that this result they have found out was totally wrong. But they have published it. I don't know why. I have sent them an email. Please put all these out of the internet. It's wrong information, and try to approve your gravitational idea, because they call themselves an institute for gravitational research, and they have not found anything out for what they have as their title. So they only are trying to find some ideas in fields they are not interested in, and they have no expertise and experts in the group. And you see, but this is in internet, and this is not very good for me, and it's not helpful. Well, I can stand it anyway, but you have to pay attention what you read in internet, especially from those who have not used this experimental kit. Well, it's only to demonstrate, this system is only to demonstrate that scalar waves exist, always in a combination to the electromagnetic wave, but with different properties. This is why we have done it. And in this documentation, there are some interesting effects. For instance, if you ask what is the influence of this coil. You see, this flat pancake coil, it's called. This flat coil has very special properties. And if you want to prove this, you only have to change the connection in the center and on the earthing connection, which is outside of the coil, this inner part and outer part. If you change both, then all the scalar wave properties disappear. And so that you can say these coil, how it is produced, has an influence and to what the properties at the ends are, so that the scalar wave and the special properties of scalar waves, they totally disappear. And if you have a standard coil, if you change both connections, there's no difference. So this was in interest to Nikola Tesla himself, and he said that this coil has these very special properties, so he was writing a patent about this coil. And this coil and bifilar coil and so on. So these ideas are proved and provable, and you can all reproduce with this experimental kit.
And perhaps one short notice: you show one of two kinds of scalar waves. You show here the electric scalar wave, because not to get confused, there is also a magnetic one which you detected and which is biologically very active.
So the magnetic scalar wave is not described in any textbook, so this is totally new, but I have found out that the magnetic one is usable or is used in biological systems. That means all these ring systems we have in the organic chemistry, like the benzene ring or the pyrimidine ring, which are in the DNA. These ring systems are acting as antennas for magnetic scalar wave. But this is a bit different problem, and I discuss it, if you want, in another session, especially for these magnetic scalar waves. But this was a reproduction of Tesla, and he was the developer of the electric one. And this is why till this time we have in internet only two descriptions about the electromagnetic wave and about the electric scalar wave, Hertz and Tesla. And I have found out the third one and have developed it, derived it and described it, and now I show that this is usable as well if you for biological effect, the magnetic scalar wave. But you can use this system as well in addition, in combination with the magnetic scalar wave, because at the top of the ball of the antenna we have a maximum of the electric field strength, and you are able to measure all along the coil and all along the line, you find out where the minimum of the electric field strength is, but the magnetic field strength is just the opposite. So it is on top 0 and has a maximum at that point where I have put the excitation or the primary coil on the button.
And that's why medicines have put medical products on that, and then
they always have to put the products on this point where this coil is on the other side, because here is the maximum of the magnetic field point.
Yeah.
So this is what we have measured, you see, and we have found out that there is the maximum of the magnetic field, and the magnetic field is the one who is accelerating the electrons in such a ring antenna, like benzene ring. Then they are moving, and then they are accelerated, and then they transport the biological information to the coil, to the magnetic fields, and the magnetic fields are involved with the electric fields, so that we get a wave, an electric wave, which is carrying the magnetic wave and the information of the magnetic wave. And we are able to transmit over long distance these biological information.
And perhaps one short word, you always say a wave which is electromagnetic, the usual one from Hertz, has always a part with scalar waves and vice versa. Yeah. They are always combined in some way.
Yeah.
That's also important to know, because I thought as a layman there's only this one and this one and this one, but in nature
it's always mixed up. It's always mixed up. An antenna with 100% efficiency is not existing. That means we have standard antennas with efficiency of about 80%. Let me say. Well, we know this. I give you an example of the mobile phone antennas. You know that the mobile phones...
The towers.
The mobile phones. Well, the machines...
Also, the antenna here...
The old one, they had an antenna you have to pull out.
Yes.
And so this antenna was maximizing the result for the electromagnetic wave. And so they have had at the beginning about 80% efficiency. Only 20% we have had losses, which are originally field vortices, scalar waves, parts, 20% scalar wave,
noise.
And they are detected as antenna noise. And if these, I call them field vortices, if they decay, they produce heat. But this is only 20% if you have an ordinary antenna. But mobile phones of today have no antenna. They have inside the machine, they have some antennas inside with a very, very bad efficiency. And they have done it because a lot of critics came who said you have to reduce the electromagnetic wave, the limits of the electromagnetic wave have to be reduced. And then the industry first said no, we don't want, but then they said okay, let's do it, and they were reducing the electromagnetic wave by reducing the efficiency, so that the machines of today have not 80%, they have perhaps 40% efficiency. That means they have half of the efficiency, and by this they have half of the electromagnetic waves. And this is what the customers wanted.
But it's the other way around when it comes to the health. Because then you rise the part of the scalar waves, and that is the damaging part.
So it is. That means what we are radiating is a noise. We know that everybody is radiating noise, and so the noise signals are the one who have a biological effectiveness. And this is the scalar wave part. And the scalar waves have not, by the reduction of the electromagnetic waves to the half, have been now accelerated from 20% to 60%. That means now they are 3 times more. And this is the problem, that we have now machines with 3 times more biological waves than we had before. And the next problem is that the masts on the other side, which are communicating with the mobile phones, the masts, the antennas of the masts, had to reduce the efficiency of the antennas as well, because you see, if one is using less electromagnetic waves but more scalar waves, the mass has to do the same, because the scalar wave is not shieldable. And this is why today they are in a Faraday cage, in an oscillator, or in a lift, in the underground railway, in other Faraday cages in the car, for instance. They are all phoning all the time. They are phoning, you see, and it is much better working than it was before, because now they use more scalar waves than electromagnetic waves, and so the effect is much better. It's not shieldable, and this is why the mobile phoning of today is, from a technical point of view, it is improved, but from a biological, it's just the opposite. It is, it makes us ill more and more.
Because the body don't bother about electromagnetic waves. There's no resonance.
No, the electromagnetic waves, there's no resonance, because we would have, or we need antennas which are just in the right size, and we don't have these antennas.
But we have a lot of antennas for the scalar waves.
Yeah, the scalar waves, they could, well, they are changing the size, so they can become very, very small, and they have the ability to tunnel. You know perhaps about the tunneling effect, when the signals are getting smaller, run through the tunnel, but then they are quicker than the speed of light. So this is a proof that the scalar waves are always involved with the other ones, and that they have other properties. So we still know about all these things, but we have to accept it in theory. And what I say is, we have to always look at the wave equation, because the wave equation shows that both waves exist in one equation, because the Laplace operator may be divided into these two parts, the one describing electromagnetic waves and the other describing scalar waves. And if we have always this mixture, what we can do is produce antennas like this one, which is improving the scalar wave part, or using a dipole, a standard dipole, improving, and an ordinary antenna, improving the electromagnetic part.
Yeah. So mankind choose the wrong technology when it comes to the cell phones and things like that, and when it comes to transport electricity.
Yeah, as a teacher, as a professor, I can say they are not well educated. So we need better education. That those who learn about high frequency technology know more about the wave equation, and what the wave equation tells us, that you cannot look through one eye, see the electromagnetic wave and shut the other one, or you see the scalar wave and you see this is not one. It's only one-dimensional. It's not telling us what the truth is in physics. We have to open both eyes. We have to see everything, and I think this experimental kit is helping you opening the eyes.
Yes, thank you very much.
Yeah, thank you for the interview, Henning.